So hello, good afternoon. My name is Tamas Gelesz, and today I would like to tell you a story about an architecture assessment. And this story is about microservices, domain-driven design, and also some ways of how to assess an architecture. But before we get into the details, let me say a few words about myself. I work as a solution architect at EPAM, and I usually do architecture design, review, and consulting for customers. I usually focus on cloud, microservices, web, and sometimes on API management, event streaming, and analytics. And earlier, I used to be a Java developer. And I come from Hungary. I live in Budapest. So this is how I would like to structure my presentation. First, I would like to talk about the context and goals. Then there will be a longer section about the structural assessment of microservices. Then we will look at some other quality aspects of this architecture and action plan. And then I will summarize some takeaways. Let me give you some context on what this case study is about. So imagine that we have a large client. I can't really say more about it, but it's a Fortune Global 500 client. And one of the departments of this client built a microservices architecture, but they didn't have any experience with microservices before that. So they asked somebody, who became me, to assess their microservices architecture. From a functional perspective, this system is more or less simple. So imagine that there is this large company, and they have a lot of applications with a lot of UIs. But these UIs are not customized to any industry. They are generic. So they built this system to customize their UI text to various industries. And here you can see the examples. So in the generic UI, you would see factory and client. But if we customize this UI to healthcare, then factory becomes hospital, client becomes patient. Similarly, for education, factory becomes school, client becomes student. So more or less, this is the high-level context. So this is what they asked from me. They basically told me that I should assess their architecture. They were interested in the overall quality of their architecture, what they were doing wrong, what they were doing well, is there anything that they can do, some cost-benefit assessment, recommendations, and kind of like a prioritization. So as you can see, this is kind of high level in terms of the task. Their approach was the following. So they basically gave me some engineers time that I could use for the assessment, but they didn't give me any structure on what they expected. And they expected me to drive this assessment. So you can see that there is a lot of freedom in this exercise. So I started thinking, how should this be done? I mean, they don't really provide anything structural for me, so I needed to come up with a structure. So I decided that I need to first identify these things. Firstly, why are they doing this? What is the strategic importance of this assessment? And in this case, it was requested by the engineers because they had budget for quality assurance. Number two was, what is the scope of the assessment? And who will be actually reviewing this? Here, in this case, this was about solution architecture. It was not about processes. It was not about organization. And it was meant for the engineers. Number three, what are the business drivers? What are the product goals, and where is this product in terms of its life cycle? So they gave me some detailed documents, but I wasn't quite sure about this point. And in terms of the stage, this was before production release. Number four was, what is the architecture design, and what are the architectural decisions? Again, they gave me some documents, but it was hard to understand everything. So there was a heavy process on their architectural documentation and design, but it wasn't quite clear for me as an outsider. And lastly, what are the existing systems? So I got access to all of the documentation, source code pipelines, monitoring, the runtime platform, and issue tracking. So here, a lot of input. So I needed to come up with some high-level understanding. This is a very high-level view of the system and what it does. On the left side, you can see source systems. So these are the systems which have the texts in the UI that need to be customized. And there is this process of importing these standard terms, applying a rule-based transformation, and then doing some manual review and corrections. And then we get to the customized texts, which are customized for various industries, and these are fed back to the source systems. Here on the right side, you can see that there is a query interface for these customized terms. And in terms of structure, like a technical structure, this was made out of several microservices, kind of like a dozen. Some of them were web UIs. And the way they built this was with domain-driven design. And in some cases, they even used event storming. But they considered that each backend would have its own bounded context. Integration was also quite up to date. They used messaging with the choreography pattern, but each service persisted each input, their inputs. So here I started having questions already. First question was that, okay, this design methodology and the system is quite modern, but does this really fit their use cases? Have they maybe done domain-driven design too much, like overdone it? What are the quality attributes of this system? What are the non-functional requirements? What is the data quantity? And what are the query use cases here? So I didn't have any questions for these. I didn't have answers for these questions out of the documentation or with consulting with the engineers. So I started writing an assessment report. And this assessment report was in the structure that you see here. It had one large introduction, and then it had a list of aspects, like quality attributes mostly, and in each aspect, there were issues and recommendations listed. Each of the issues had a category of severity and also kind of like a high-level estimate on how much it would take to correct this issue. And here are the first issues that I collected. The first aspect is business alignment. I said that the quality attributes are not clearly defined and the query use cases are not specified in detail. In the documentation category, I also stated that the documentation is fragmented and partially outdated. You can imagine some of it was in old Word documents, some of it was in source code, so it wasn't really an up-to-date and easy to understand documentation. And also I mentioned the steep learning curve. So let's get into the structural assessment of the microservices. Until now, you have seen kind of like a top-down, high-level vision of this structure, but there were questions that I couldn't answer based on that. So I started going from bottom to up, and I looked at source code. Here, I don't think you can read this, but here are simple shell commands that I ran on the source code to generate this table. In this table, you see the list of components on each row. The first one is a shared library, which is used by most of the backend components. And here you can see the technology. It's Java, TypeScript, JavaScript, lines of code, if the component uses the shared library, number of messages consumed and published, number of database entities and API endpoints. And here I started having questions again. So these guys were talking about a microservices architecture. But if you look closely, you can see components with 19,000 lines of code. And in some cases, dozens of API endpoints or more than a dozen entities. My questions were, are these components too large for a microservices architecture? Do they have too many responsibilities? And what's up with this shared library in the microservices architecture? But I continued my analysis. Here you see a graph of the messages being consumed and published. So the structure is, so this is the actual graph without the labels due to privacy reasons. But what you would see here is that the rectangle is a component. The cylinder or the ellipses is a message. The blue is a creation of a message. The black is a consumption of a message. And here you can see that between components, there are multiple messages being sent and received. And I was thinking, why are there these parallel messages between the same two components? Is there a problem with a level of abstraction? Are these messages too fine-grained? And also you can see that almost everybody talks to everybody. Why is this happening also? Is there a problem with responsibilities? And interestingly, there were some messages that didn't have a consumer and a producer. They only had one. I was thinking, why is this happening? Is this a quality issue? Or maybe I'm making a mistake in the assessment? But I continued with the analysis. Here you can see the same messages in a different structure. It's a table where each row represents a message. There were 65 of them. Here you can see who is publishing the message and who is consuming the message, and how many consumers there are. There were some interesting things in this table as well. Firstly, not every message had a publisher, which was strange. Not every message had a consumer, similarly to the previous slide. But there were some messages which were consumed by almost all of the consumers. The questions were, why is this happening? Is there a problem with responsibilities? And there was also a documentation, async API, which was a nice thing that they have. This is similarly to OpenAPI or Swagger, but for events. But interestingly, not all of the messages were in that documentation. So I continued the analysis, but wrote some notes for myself. This table is about database entities. Here you can see the various database entities in rows, and here the components that have that database entity in their database. Interestingly, there are database entities which appear almost everywhere or in more places. Question again, why is this happening? Is there a problem with responsibilities, single responsibility? And what's up with this thing that every component has its bounded context? So at the end of this reverse engineering exercise, I collected several potential issues. And I'm saying potential because at this point, I wasn't sure that this was really an issue. But these were the following, as I listed previously. So issues with component size, responsibilities, boundaries, tight coupling, level of abstraction, and the number of bounded context. I talked with the engineers of the customer, and they were telling me, okay, but we made this decision. So it seemed like a conscious decision. And we were talking about pros and cons, and at this point, to me, it seemed that the issues are interlinked. So you can't really talk about one thing without looking at the other thing. So I decided that I need to have a look at this whole architecture from a different perspective. I decided that I would collect the business drivers, the main requirements, the architectural drivers, and do a reference design. And then compare that reference design to what they had. And here I decided that I would use domain-driven design. So let's talk about domain-driven design. I'd like to dedicate a few slides to this to provide some more context about this. So there are great resources on domain-driven design everywhere on the internet, but I would like to highlight a few of them. There is this great article by Microsoft, which basically defines a simple four-step process to defining microservice boundaries using DDD. In the first step, you analyze the domain, the whole thing basically. Then you split it up into bounded contexts. A bounded context is a domain model for a subdomain. So part of the whole domain. Then within each subdomain or each bounded context, you define entities, aggregates, and services. I will talk about what these are in the upcoming slides, and based on these, you can identify microservices. If you have time, then please have a look at the article or the book or the course. I think it's really worth looking at these. Now let's apply these principles to this architecture. Here you can see that in the reference design, I came up with 4 bounded contexts. Here there are 2 bounded contexts which represent 2 source systems. One was a source code repository, and the other one, which I call XYZ system because of the NDA, but you can imagine it as an object store. In the middle, there is a bounded context that I call language customization. Within the language customization, I imagine that every piece of logic or data that the system deals with would be inside it. And on the right side, there is it's called a future subdomain. It's basically those who are querying things from this central domain. And you can see that there is a big difference here. In the customers architecture, they said that each backend component would have its own bounded context. What I'm talking about basically one. There is another thing that I want to mention here is that this department also worked with language translation. So from one language to another language, not just customizing from generic to industry specific, but language translation. And here I was in a dilemma. Do these things fit in the same bounded context as the customization, or would this be a different bounded context? But still, if you consider, I'm still talking about 2 bounded contexts and not 12. And one additional thing to note here is that when you do DDD, you usually involve domain experts, but in this exercise, there was no opportunity for this. So there is some place for error here, but you can see that there is a big difference. So let's zoom into the middle subdomain, the language customization, and apply the next step in DDD there. Here you can see kind of like a fairly complicated graph. I'm sure you can't see the details, but that's okay. What I would like to talk about here is what this graph contains. And that's listed here. So there is a legend here. Here we have entities. In DDD, an entity is something that you can save to a database, which has an ID. This has aggregates. An aggregate is I would say, a list of one or many entities. But an aggregate basically defines a consistency boundary. Or you can think of it as like a transactional boundary. So these entities should be kept in one transaction. And this will be important in the next slide. And also there are services. Services are basically domain logic. And in this diagram, you see these documented. And this is the diagram that I will use in the next slide to define the microservice boundaries. So let's look at some rules on how you do that. First thing is that you don't want your microservice to be larger than the bounded context, because it will be too complicated. It will involve multiple domain experts and multiple parts of the whole business. So it's not a good idea. On the other hand, you don't want to be as fine-grained to split up aggregates. So you want to keep the aggregates in the same microservice. The reason is fairly simple. So aggregates define consistency boundaries or transactional boundaries. If you split up an aggregate, then you need to do distributed transactions or sagas. And both of them are complicated. So if you can, put all of your aggregates in the same microservice. And lastly, the domain services are also a good candidate for a standalone service. Now, these rules aren't definite. This will not give you a definite answer, but you should respect these. There are other factors that you need to keep into account. But in this case, here in this table, I listed all of the aggregates and services from the previous diagram. And I started assigning these to microservices. So what is contained in the same microservice? This is what you see in the middle column. So in this case, these three would be in management service. Here, these three in source integration service, and so on. If we compare this to what the customer had in their architecture, which is listed here, you can see that there are mismatches. And you can also see that the customer didn't always respect these rules. So the granularity is different. And we had a discussion about this with the customer. I shared this with them. We talked about this. And they were like, okay, we see your points, but something is missing. Something is not right. So they felt that their architecture was solid, but they also understood my reasoning. So this got me thinking, what is missing? Maybe something is wrong with the inputs. So we had a series of discussions. We talked about requirements. We went back to business drivers, and we were able to identify what was not used as an architecture driver for the reference architecture. And these are the following. So it turned out that data quantity is quite large compared to what I thought. So all of the texts are hundreds of gigabytes. They didn't know this, but I insisted for them to give me an estimate. And it turned out that they have hundreds of gigabytes of text that needs to be customized and also queried. Number two, they have a fairly heavy process on creating new components. So if I recommend to them that you need to create 5 services, then they have a heavy process of creating 5 components. They would be easier with having a single component. This is definitely a constraint or a driver in architecture. Number 3, we talked about requirements, and it turned out that probably in the future, the users will want to have the standard text and the industry-specific customizations in the same query. And this is something that they didn't know about, but when we looked at business drivers, this seemed to be quite logical. And now if you look at this, the data quantity that this needs to be combined in queries and the heavy process of creating new applications, then you need to get to a different architecture. And this is the second round of the reference architecture that I came to. We have less components, less granularity, and the standard texts are stored in the same database and component as the customized text. This is the architecture diagram for the second iteration of the reference architecture. Again, probably you don't see the details, but you see that it's less complicated and it's more compact. And after this, I would like to highlight that if you don't know the quality attributes and the business goals well, you're in risk of producing an architecture that is simply wrong. And this is what happened in the first iteration of the reference architecture design. So let's summarize the structural assessment of the architecture. In the end, the most components identified by the revised reference architecture had a one-to-one mapping to the architecture that they came up with, but the responsibilities were different in some cases. So you can see that this approach, when you consider quality attributes and business goals, this helps you identify architectural significant requirements. And also this methodology of challenging an architecture, going back to the inputs and comparing it with the reference, this has its benefits as well. At the end of this exercise, I defined these issues. So number one, the standard text and the customized text are not owned by the same component in their architecture. Most of the components were coupled with the input formats of the source systems. So this created dependencies throughout the whole system, which can be avoided. And lastly, I mentioned that there was an automated process of translating, customizing text, but this was done in a very particular way, like regex search and replace terms. And I was saying to them that you need to make this more abstract, more flexible, because if you want to introduce machine learning in the near future, then this system won't be flexible enough. So this is the summary of the structural assessment. While they were saying that they wanted input on the microservices mostly, I looked at other aspects as well, because I wanted to give them a complete picture. And here are the other attributes that I looked at, the other aspects, and here are the issues that I identified. So the first category was performance and scalability. It turned out that even though that they had load testing, they didn't finish the load testing, which practically meant that they didn't know the limits of their system, which is kind of like an important thing, I would say. I also mentioned that they were storing all of the messages in the databases, even though they were using a persistent message broker. I told them that, well, this might be a bottleneck. So think about this. You can use the message broker to store messages for a while. The second category is consistency. So they were following the pattern of at least once delivery, but the processing wasn't idempotent. I highlighted some issues here as well. Another issue with consistency was that they were using these rules to customize the texts, but they didn't version these rules. And I think this is a problem with consistency. And lastly, when it came to manual data correction, the processes weren't really mature, so it was error-prone. In terms of maintainability, they had no distributed tracing. They didn't monitor all of the meaningful signals, so I recommended to them to check out the 4 golden signals from Google. In terms of availability and reliability, there were issues with the message broker because they had some problems with setting the memory and disk thresholds, and they were running on public cloud in a single region. I told them that, well, just think about this single region thing. You might not need it, but you need to think about availability SLAs as well. If we go forward to extensibility and deployability, one of the issues was that although they used async API, they didn't version it, and they didn't generate any code, any models from it. And there was this thing about having a shared library. Now, some people who work with microservices say that you should not share anything. Some other people say that, well, it's practical to share, but you need to keep an eye on the responsibilities. In this case, I was recommending them the second thing. So I was telling them, you need to keep an eye on your shared library. It's not named very well. It was named like shared common or something like that. So you need to look out for not making this too big. And in terms of usability, there was a minor issue, but it was worth mentioning, that their front ends, there were multiple front ends, which looked like a single portal, but they actually behaved differently. In the end, I collected around 3-4 dozen issues, and what was helpful for me are the resources that you can see on the slides. So I considered the 12-factor application, this article on O'Reilly on microservices, anti-patterns, and pitfalls. This is an excellent article. I really recommend it. And also this book on event-driven microservices is something to consider when you are dealing with a system like this. In the end, I came up with a prioritization of issues. I categorized them like this. So number 1, you need to get your architecturally significant requirements in order first. You need to understand what are the quality attributes, what are the non-functional requirements. Until you don't know that, you can't be sure that your system will be okay. And one of these were the query use cases. So how do you expect queries to be run? What are you combining with what? This can have a massive effect on how you store data. Number two, you need to make the existing system, the baseline, reliable. First, you need to finish performance testing to find out the limits of the system. You need to address the issues with the message broker, and you should probably add distributed tracing. Number three was making this system future-proof. Firstly, please consider the responsibilities of the components. Once you have done that, please think about the potential bottlenecks that are highlighted in the reference. Here, if you shuffle around the responsibilities of the components, the bottlenecks might be elsewhere. So first, get your responsibilities right, then look at bottlenecks. And then have a look at all of the items that deal with reliability and consistency for production. Number four, you can work on delivery efficiency. Firstly, please establish frequent production releases and then look at all of the items related to this category. And meanwhile, while you are doing this, please work on the documentation. This was basically the plan that I suggested to them. So let me summarize some takeaways based on this case study. Firstly, it's essential to understand the goal and scope of an engagement. You need to understand who is paying for that, and focusing on creating value for them is key. And you also need to understand the stakeholders, so who you are working with, who will be affected by what you are doing. Secondly, it's absolutely essential to know the quality attributes and the business drivers when you're doing architecture design. In this example, you see that the attribute of data quantity and the queries wasn't clear in the beginning of the reference design, and it resulted in different architecture. Number three, I think this is an interesting thing. So if you use latest and greatest design, that might actually not fit your use case. So in this architecture, we saw domain-driven design, event storming, event-driven systems, choreography, so all of the cool stuff. But in the end, if you consider this system, if they had created an extract and load system, a simple ETL, it might have been better. Number four, I recommend for you to understand and use the basic concepts of domain-driven design when you decompose a system. I'm not saying that you need to go full-blown with DDD because it can get complicated, but it's good to understand the principles, at least what are written in the article that I suggested. The next is that if there is a system that is already built, please value that. Please recognize that, because that's something that's working. If you are proposing to deviate from that system to build something new, then you need to think of the disruption cost. And lastly, this is a personal thing. I think it's really great to do review. If it's not architectural review, you can do code review or any kind of review, because it really helps you grow. I mean, the reviewer as well. And in the end, this particular case was something that I really enjoyed. And this is why I wanted to share with you today. So at the end, I thank your attention. And if you have any questions, then please tell me. Yeah, there is a question there.
Hello. Thank you for the presentation. It was nice. I just wanted to ask if they thought anything about exception handling or replay strategies or something like that. Exception handling between the microservices.
Well, there was a point about this. this one actually. So they did consider some exception handling, and they were storing the incoming messages because they wanted to handle some of the exceptions by automatically replaying and retrying. But this wasn't a foolproof solution. And in some cases, they actually had to go into the database manually and correct the things.
Thank you.
Welcome. Oh, there's one.
Thank you. I have a question about aggregates. First of all, what did you prefer to do with aggregate? Combine it to one microservice or use something like Saga with them? And, sorry, kind of second question. Which practice you used for recognizing the aggregates?
So the question was about how I used aggregates and what sort of transaction handling I used. So the way I came up with this is that I analyzed the requirements and I thought of what belongs together. Usually you would talk with business owners or domain experts to identify what sort of data should be held in a transactional boundary. Event storming is a good practice to do this. So yeah, this is how I identified what is contained in one aggregate. So the gray boxes mean one aggregate, the white boxes are the entities, and this is the root entity. And in terms of, you asked about sagas, if you put one aggregate, so if you don't split up one aggregate into multiple microservices, you probably don't have to deal with sagas because you're not splitting up the transactional boundary.
I'm sorry, I didn't understand. If you split into the, maybe I didn't hear it properly. If you split it into the different microservices, we cannot use Saga because this is a different transaction. Sorry?
No. I'm saying that if you keep the whole aggregate in one microservice, then you are not splitting the transaction into multiple services. So you have less problems with sagas.
And what did you prefer? Which of these two approach did you prefer?
Well, I suggested to them that you should not split up aggregates into multiple services.
Got it. Thank you.
Welcome.
Thank you for the presentation. Just a curiosity question. What in the end was the reasoning behind the messages without producer or consumer?
I'm sorry, I didn't understand.
What was the reasoning in the end behind the messages without producer or consumer?
We didn't really talk about that, but I think it was that it was deprecated. So that was my logical conclusion. Here you can see that some of it was not even documented in there. So here, this is what is documented in the async API, and there is some overlap in some cases. Oh, and also there is one other thing. There were producers which were outside this microservices framework. So that's why probably some of the publishers are missing. But for the consumers, I think they just started throwing the messages, but they didn't get there yet. I mean, just to make it future-proof.
Okay, for you, which is the right time to force for a customer to ask for a assessment like that?
So what is the right time to do an assessment?
Yes, because I think before going to production, it's a little bit late. to reconsider all this stuff.
Yeah, that's true. So there are various stages when you can do assessment, and the sort of assessment that you do in that stage is different. So here, when you are before production, this is mostly about identifying risks and the risks of going to production. If after this assessment they need to do some fundamental changes, then that will either delay the production release or it needs to be handled on a longer term. But you can also do assessment in an earlier life cycle. So when you are still only talking about how you would decompose the system into bounded context or where your service boundaries would be. Okay, I think that was the last question, so thank you very much for your attention.